Q for discharge is equal to Q naught initial charge multiplied by e power minus RC minus T divided by RC. Okay, but the problem here is now that we don't have the Q naught value. We have capacitance, we have potential difference, but we don't know what is the initial value of charge. The Q naught value we don't have. But luckily we know the formula. Q naught is equal to CV. That's the total charge on the capacitor. So Q naught is equal to capacitance 0.2 into 10 to the power minus 3, and then we got potential difference, which is 12 twos are 24, so it will be 2.4 into 10 to the power minus 3 coulomb. That's the Q naught initial value of the charge. Okay, and now we use the above formula. Q is equal to Q naught e power minus T divided by RC. So Q naught is 2.4 times 10 to the power minus 3 exponential, and then we got time, which is minus 1 second divided by R. Here we have somewhere a resistance 50 kilo ohm, so it's 50 into 10 to the power 3, and then we got capacitance, which is e power. Okay, let me just write it here. 2.4 times 10 to the power minus 3 e raised to the power, how much is it? Minus 1 divided by resistor 50 into 10 to the power 3, and then capacitor 0.2 into 10 to the power minus 3. Okay, so now what we need to do, we need to multiply 50 multiplied by 0.2 is 25. 50 multiplied by 0.2 is 100, so it will be 10 and 10 to the power minus 3 and plus 3 will cancel out, so minus 1 divided by 10, we got 2.4 into 10 to the power 3 minus 3 and e power minus 1 divided by 10. Just solve it now. Minus 1 divided by 10 is 0.1, so we got exponential to the power of 0.1. Okay, and we get 2.171 times 10 to the power minus 3. So charge on capacitor is 2.171 times 10 to the power minus 3 coulombs. Okay, so that's how we can find the discharging of a capacitor.